In this tutorial, we'll set up an animation blueprint to use the full body IK system. So we create an animation blueprint using a standard anim instance and the UE4 skeleton. Let's rename it to something which we can find later. And now, once you have the plugin installed, you can access the full body IK node. And let's connect that to our final animation pose here. And this node also needs an input pose to drive the animation. You can use anything as an input, but let's just use the idle pose for now. Let's compile. And as you can see that we can see the final idle pose animation coming through because the full body IK node currently doesn't do anything else. So there are two main inputs. One of them is the effectors, which drive the end points of the skeleton hierarchy, and the constraints, which put constraints on various joints. So we have spherical constraints and hinge constraints. We'll look at them in a little bit more detail at a later point. So to start working with the end effectors, we'll first set up the IK bones, which are being controlled by the end effectors. So we'll set up 4 bones in this case to be driven by end effectors. 2 of them would be the feet because we want to make the character grounded, and the second and the third one would be the root, because we also want to constrain the root to prevent it from moving around if only the endpoints of the hierarchy are controlled. And then the final is the neck joint, which we'll use for the character to turn him around while standing and walking. And always make sure to identify what is the root joint of your skeleton. So in this particular skeleton setup, the root is called the root, so that's easier. But you can have skeletons where it's not called the root. So this is just to identify what is root. And I noticed I changed the final effector to pelvis, not to root. So here we see the pelvis is at the pelvical bone. And then the root joint, if I can click it, let's go to the skeleton. It's easier to pick it here. Here, the root is located at the origin in this case. So now let's add, we can add constraints and effectors here. So let's start with adding some effectors. So since we added 4 IK bones to be controlled by end effectors, we'll add 4 elements here to the effectors. And for the first 2 are going to be the left foot and the right foot, and let's put a weight of 1. Weight determines how strongly these IK bones are will be pulled towards the end effectors. And this use transform from input actually just uses the input animation to drive the transform of those end effectors. So right now what will happen is that the feet will just stay where the animation dictates them to be. The root, we're also going to make it stay, make it control. We're going to control it using the animation, or we can control it using our transforms. So the second one, and the number 2, which is actually the third effector, is the neck joint. So here I'm like giving it some transform. So we want it to be rotated vertically. So I put some kind of rotation, 90 degrees, close to 90 degrees, because and then the root is also the pelvis is controlled by the animation. So this is the output of the IK algorithm. So one thing is to draw the effector size boxes. We can control them by adding the effector draw box sizes inside the full body IK node. So here I'm making them all of size 3, but it still seems like small to notice in the fully shaded view. So let's make it bigger. Let's make it 6 so that it's quite obvious where the effectors are, even when you're in the shaded and not in the wireframe mode. So there you can see the end effectors more clearly. and there is also an end effector on the root, which is going to drive the position of the root. So now let's try to move these effectors around and see what kind of output we get. So here, since there are no constraints on the skeleton is allowed to move wherever. So you can see like we get this weird solution, which will very quickly fix by adding some more constraints. But the IK node is doing its job. It's like finding the solution for the skeleton orientations and positions internally by using the end effector transforms. So now let's begin by adding some constraints. So we'll add a bunch of constraints. So let's quickly first go back to our node and add the bones which are going to be constrained here. So first we definitely want our pelvis to be constrained. So that's the first constraint we add. And then we'll add 3 more constraints for our spine bones. So spine 1, spine 2, spine 3, they're all going to have constraints. And then 1 more for the head and the neck joint. So now that we are done adding the constraint joints, we'll quickly compile, and we can compile later. We can add the constraints in our constraints variable as well. So we will need 5 constraints because we added 5 constraint bones in the IK node. Later, in a later build, I would like to have some more information about what constraints bones are being used here in the constraints variable. Right now you kind of need to remember what bones are at what positions in the array inside the IK node. So I'm making all of the constraints as ball and socket constraints. So now let's go back to our node to see what the first constraint was. So we have pelvis, we have the 3 spines, and we have the neck. So let's try to remember that when we try to set up our constraints variables. So here for the pelvis, so these 3 variables actually are used for hinge joints. So let's ignore them for now. So theta and twist are the 2 joint limits for a ball and socket joint. So we set it for 2 degrees and 2 degrees for the pelvis because we really don't want it to twist or to have any swing joint. We want it to be fairly rigid. And then for the spines, I'm setting 30 and 30 for the theta and twist. You can play around with those values. You can look up, you can try to move your skeleton and see what works for you. I'm just trying for the purpose of this tutorial, I'm just trying some generic values. And for the spine, which is connecting to the neck joint, I'm giving a theta of 2 degrees, but I'm still allowing it to twist. So now let's try to rotate the end effector, and then we can see that the twist constraints are being satisfied because the spine doesn't rotate all the way, but it tries to follow the end effector and then gets limited by the twist constraints. So, but we can see that the neck was not rotating. That was because the inherit anim rotations was turned on. And that means that the end effectors will inherit the rotations coming from the animations. So let's just create a variable to easily control it to turn it off. And then let's try to rotate our neck again. And then we can see that the neck now rotates along with the effector. Well, and this all happens while the skeleton is playing animations for the incoming animation sequence. So now the constraints are in place. If you try to move the effector to places which cannot be reached, then you might get some weird solutions. So you want to keep your constraints like close to places which are plausible. It's okay to stretch them, but squashing them to places can cause issues. So now I'm trying to move the root joint, and you see that the entire body follows the root joint. And there's some weirdness going on in the knees. You can see that the knees are not supposed to bend that way, and that happens because we haven't set constraints for knees or for thighs yet. So knees are special in a way that they are controlled by hinge joints. So right now I'm going back to the node and setting up some constraints for the thigh joints and the calf joints. The calf joints are the knee joints, basically. So now, after setting those bones up, I'll set up the corresponding constraints in the constraints variable. And again, I'll set up ball and socket joints for the thigh. So let's set like 60 degrees for the theta, and maybe like, I don't know, 30 degrees for twist. Similarly, this is for the other thigh. So again, 60 and 30. 30 for the twist. However, for the next two joints, we're going to use hinge joints. So the hinge joints also need more input in the form of a pull vector, which is where the hinge joint is pointing towards. So let's try to first use the pull vector constraint location, which specifies the global location of the constraints. That's the first way to specify a pull vector. So here I'm just trying some values, and once we compile, we'll be able to see it. So here you see the red boxes that show up. Those are the locations of the pull vector constraint. So that's where the knees will be pointing towards. So there's some weirdness going on in the knees right now, and let's go to our preview and let's try to move around to see. So the pull vector constraints location were swapped. The left was where the right should have been, and the right one was at the left knee location. So they were pointing towards each other rather than away, which is usually or towards the front of the character, which is usually the case. So here now I'm fixing it in the default values for the pull vector constraint locations. Now let's try to go to, if I can remember, go to the preview window and try to move these constraints, pull vector constraint locations around. You can see the knees follow them quite nicely. So now if you try to move your character around using the root end effector, the knees will behave nicely and will point towards the end effector. So now the second way to control is to use a local constraint, which is defined locally in terms of an end effector. So here I turn it on, but the local values are turned to 0, so that we get some weird solutions. But as soon as I change them from 0, so I'm going back to the defaults and I'll do that again because I forgot to go to the defaults window. So here now I'm setting up the pull vector for local control. So the pull vector effector ID is the effector which drives the pull vector, and 1 is for right, like in this case, right foot, and the effector 0 is for the left foot. So you need to make sure that you input the correct one. So now once you turn this on, you can see this red arrow which points to the direction of the pull vector constraint. So now I'm trying to set some values which kind of make sense. So you can play around with them in the preview window, and once you find some values which you're happy with, then you can go back to the defaults window and set them up to be compiled and saved for later. So I'm just here now trying some values. So if you set it to 0, then that's like results in a weird solution. So yeah, try to keep it to like non-zero values and like point it somewhere. Usually like towards knees usually point towards the feet direction, like where your feet are pointing to, but they can point to different locations. So you can animate these like by providing values to these pull vector constraints as input to the animation blueprint, and you can change them with the course of time, or you can keep them fixed if you don't want to mess with them all the time. So using the local pole vectors works out quite nicely, because you can just focus your attention on moving the end effectors, and then the pole vectors kind of take care of themselves by orienting the knees in this case towards the feet direction. So now I'm trying to disable the transform control on the right foot. So you need to set up the rotations for that correctly so that it is pointed in the correct direction. So I'm trying to find a value, and here. So now it is pointed to correct orientation. So as you can see, when I rotate the ankle, the knee also points in that direction. So it maintains the offset which we have set up using the pole vector local constraint location. So you can change the input animation to a walk, and let's see that what the output looks like. So now the neck is kind of behaving weirdly, because it's like trying to keep the neck fixed where it's moving up and down, so that caused a weird solution. So I just moved it a little bit up, and then we get better solutions. There's some weirdness going on in the knee, because we noticed that the knee pole vector constraint is pointing a little bit too much outward for the right knee. So there I went and fixed that. So now let's try to rotate the neck joint while the walking animation is played. So you can see, sorry, I meant the neck end effector. So you can see that the skeleton behaves correctly in response to all the constraints and the effector location